Hello everyone. Today we want to create ADF pipeline, Azure Data Factory, and for this practice we want to think about a real case scenario that is very common in the business and industry. For example, we have many CSV files and then we want to transfer them to a kind of structured data as SQL. To create it with ADF, we want to somehow implement a pipeline that do this flow automatically. To do this project, we go a step by step to implement it, and it is, I hope that it is a very good practice for us to learn together uh, Azure Data Factory and a nice practice. Okay, for the first stage, we want to see what is the scenario exactly. Uh, Imagine we have three CSV file, one related to customers, one related is about the products, and one is about the orders. And these files are CSVs and include some information about the customer, products, and orders. And it is many-to-many relationships, many customers, they are related to many products and vice versa. Therefore, we use an intermediary uh, table or file as order that connect these two together. Okay, for the first, we go to Azure Data Factory, and before that, all the CSV files that we have to store should be in the blob storage, and the tables that we want to create must be in the SQL database. Okay, we start from the input storage that should be a blob storage. So we create a blob storage. We go here and then click on the create. For this practice, to start from the scratch, we create a new resource group. Okay, call it incremental demo. Okay, it's enough. And then storage name demo storage CSV. Then for the region that is close to me is the Belgium, but you can choose uh, what region you like, and then review and create. Okay, create it. After the creation, we go to the resource groups, pull up service, and then create a container, call it input, and create a container. Inside the container, we upload the CSV files manually. The CSV files that I have are these four CSV files that I will explain to you one by one. Okay, two customer CSV, one order, one product, to see what information there are inside them. For the first time that we see for each file, there is a kind of date that relates to this. It shows that, for example, in first date, we have some customer. In the second date, we have another customers, and in between, we have some kind of duplication. To prevent this kind of duplication or deduplications, we need some kind of strategy to eliminate those repeated records. To do this, we have to think about it, and I have some strategy that I will explain during implementation. But as you can see here, we have customer ID, name, country, file date for the first customer file, for the second, as you can see. Okay, for the first, we see we have Bob, customer ID 2, and also here for the next day CSV file for customer. Also, we have a Bob with the customer ID 2. To prevent the or for the final table that we want to create, we have to notice that we have to prevent this duplication. For orders, we have these orders that refers to customer ID, product ID, and order date, file date. And products is information about the product and product ID. But here, something that you have to see here, maybe it's interesting. Here, for the customer ID, we have one, but we have four. But as we saw, we don't have a customer ID 4. That is something that shows that this CSV file includes some inconsistent or wrong data. So it is another issue that we have to think about it. So because we don't have a customer ID 4, but it is refers to 4. So we have to think about it. To have a strategy that we can somehow handle this duplication, I want to implement such pipeline. First, we have a CSV file in the Blob Storage. With the Azure Data Factory, we want to transfer them automatically, all files to a kind of tables, but we have intermediary tables. They are not final tables, that are some tables as a staging tables that include all information, including wrong data, duplication, and so on. And after that, after transferring all CSV files to separate staging tables, each for the customers, product, and orders. After that, based on some kind of stored procedure, we try to fit right and correct information to final tables, and the wrong data that we saw, for example, the order refers to customer ID 4 that we don't have a such customer, goes to error tables. Very simple. From CSV, some kind of cleaning here, we create the final tables. Okay. Without further explanation, we go to continue implementation. Okay. After creating the blob storage, we want to create Azure SQL database. We go to Azure SQL database and then create Azure database, resource group, uh, resource group is incremental demo that we created, name data, database SQL. That's okay. Server, create a server or server demo CSV, and it is correct. Belgium, correct. For simplicity, we use SQL authentication and use server admin logging, server admin for the ID, password. We choose a password. Okay. Okay. Here for the compute and the storage, because for this sample demo, we don't need too much storage and computation. We use the basic, apply, yeah, and then create. After the creation of both SQL database and server, we go to the resources and we see that we have a SQL database. To enter this, to write a kind of query, first we have to log in into SQL Server based on the password we set for. Yes, something that we have to notice is we go to the resource, incremental demo, and the server demo. We have to go to networking. When we go to networking, we have to enable selected networks and add or IP that we are using, and also allow Azure services to connect this SQL server, save it. We back to SQL database, query editor. Okay, here we want to create or a staging tables that we explained. We have some staging tables, staging orders, products, customers, and final tables. Therefore, can be customers, products, and order. And for the uh, error table or rank table, we have to create a kind of additional table as the error table or rank table. We have to create the table and the headers or schema of each table one by one. Okay, for the staging tables, we have staging customers, products, and orders. Uh, the same columns or header at the CSV file. We have customer ID. We define that it should be integer, name, character, and country, and 5 dates. Also, same for the products and orders. Then we run it. Uh, I try to clean this code, and now I run it, and we see that we have the uh, staging tables. Also, we have to create final tables uh, to feed the records finally that are very correct and precise. To do this, I copy paste the SQL code of them. Okay, for the customers or product and order tables that are final tables, we have to enforce some schemas. For example, for customer ID, we say it is integer but not null, and also we define the constraint as that customer ID is the primary key. What the benefit of this? It prevent the duplication. We cannot have two customer with the same customer ID. Uh, and also we do same for the products, and for the order we have to notice that we define the uh, foreign key that we say customer ID that we have in the order table is a kind of foreign key that refers to the customers and customer ID. And also the product ID that we have in the order table, it is refers to the products tables and products ID. Then we run this. Okay, we run it, and then when we load the tables, we see we have customer table, order error. Explaining a little bit about the order error. Order errors that are some kind of tables that we created for the wrong data, as we saw that the order refers to customer ID 4 that we don't have, they store in the error tables. Okay, next we go to resources, and we check that in this resource we created that input CSV files that we want to receive is Blob Storage. The final table should be stored in the database, SQL database. So we have to create a Azure Data Factory. So we go to here, Azure Data Factory, create Azure Data Factory, resource group, incremental, demo, Data Factory, the name, it's okay. And review and create, create it. We wait a little bit to for the deployment. Okay, we go to resources, we refresh. Yes, Azure Data Factory is here. We launch Studio. Yes, we are here in the Azure Data Factory. So as I explained here, we have here in the Azure Data Factories, we have to define the pipeline that transfer each CSV file, customer CSV file, for example, to a staging customer table. To do this, we need the kind of automation pipeline that goes to the input containers and see what uh, CSV file we have in this container, and then transfer each to related table. For example, CSV, customer CSV to a staging customer, product CSV to a staging products. Okay, to create this, we go to the pipeline, and the first thing we need the link services as a key that we are able to connect the input and output resources. So we need a link service to connect uh, Azure Blob Storage that includes all CSV file that we have. Input CSV main service, then subscription, storage name. Okay, to ensure that which one is for us, we go to resources, incremental demo, that demo, storage CSV is for this resource group. We choose this, and then nothing else. We check for the connection, and everything is true, created. Now we have the link service for the input CSV. We create another one for the SQL, Azure SQL database. Here server name is server demo CSV, server demo CSV, put this, and then database SQL, username server admin, password, and test for the connection. Okay, there is a problem that we have to solve it. Okay, we back to the SQL database, and we see there is a typing error. There, the username is this. Paste it here. Test for the connection. Now it works, and we create it. So we have two link services, one for the blob storage, one for the SQL server, SQL database, and everything is okay. We back to the data sets. Now we have to create a data set, one for the CSV file and the one for the SQL table. But here, since we have again back to the file, we want to create some automation that read the input container and get one by one the CSV file, and then put in the related tables. We need three databases. I will explain during the creation of the pipeline why three, but here we need three. One, it is get all the CSV files from the input containers that includes 4 CSV files, and another one When we implement a pipeline for the for each activity, we need another data set that includes only one CSV file. So for this, we create one for the blob storage. The blob storage includes the CSV file. Name it folder CSV. It is the folder that includes many CSV files, link services is found, container that includes all the CSV file is this, and then leave it as here, and then okay. After the creation, we see that we have the connection, schema, parameters. So we go and create another CSV for one CSV file, call it file CSV, create it. Okay, after creation, we go to the parameters, create file name. Okay, before we go to the here, we have to use the dynamic dynamic content here. Then we click here, we click on the file name and it says at the dataset get the file name. Why it is like this? Because when we want to implement, we use the activity called Get Metadata. When we get metadata, it returns the child names and a list of including a dictionary, and each includes name and the type. For taking them, we need the kind of parameters that we have to put the value for each them. So with these dynamic parameters, we are able to dynamically read all CSV file one by one and then convert them to the table. For this, I think there is nothing to do. The last one we want to create for the SQL, Azure SQL database, we created for the link services this. No, nothing else. For the parameters, we have to create a table name, get the CSV file, and put the to a specific table of each CSV, and then if we check the table, I think here we explain. Here we selected enter manually. For the table, we have to choose dynamic content and then click on the table name, create it. I think we did everything correctly, I hope. We go to the pipeline, create a new pipeline, and the name of the pipeline is CSV to SQL pipeline. Okay, so here we use the activity as get metadata. It can imagine as a folder list includes all the CSV files. It provides a list of these CSV files, and with the help of the ForEach activity, we are able to read each CSV file one by one and then transfer it to related column. The first thing is get metadata activity, put it here, and then get metadata as the name. We go to the setting and then choose the Azure folder CSV. In the Azure folder CSV, what we have, the output of the metadata is something like this. We have to say, okay, when you see the CSV file, treat as each CSV file that we have as a child item. So, okay, field list, and from the argument child items. What it does, it returns the child items as a list of dictionary or dictionary in Python. Then each names includes the CSV, a specific CSV file. So I think we are done. Next, we have to add the for each. For each is in the iteration. Okay, we after the getting the list of the CSV file, you have to feed one by one or read one by one by the for each loop, and the setting we have the itemize here. Okay, here as we see, we have to get, it is the output of the metadata. What we have to do for the input of the for each, we have to say, okay, I need the child's item and the name of each, and to read each of the CSV file one by one. It says get metadata child, list of the subfolders and files in the given folders. Exactly, it gives the code that activity get metadata, output, child's name. Okay, that is good. Yeah. Now inside the for each, we have to create the copy activity. In the copy activity, we have the source and sink. Okay, we go to source. The source of this is a file-based CSV. When we open it, we go to value to give the value for each parameter we defined before. The value of this, we have to add the at item dot name. Why name? Because as we mentioned here, we have the child items, and each, it is the list. To get each of them, we have to say child items and the name to get the specific CSV file one by one. So we can say items dot name. Okay, sync. The sync is the Azure SQL table. So here we had to click add dynamic content. Here it is very important. Why we here we have to provide some uh, more or semantic information. Why? Because we have three staging three staging tables for order, products, customers, and the CSV files with mainly three names. One is the uh, customer CSV, product CSV with different date, and the order CSV. To transfer each to related table, for example, customer CSV to a staging customer, product CSV to a staging product, and so on, we have to uh, write a if condition that say, okay, if it start with customers and something .csv, it goes to a staging CSV. If it starts with here, as you can see, if it starts with the customers, it must go to a staging customer table, and so on for the other CSV file. Copy this and put it here. There is no error. Okay, I think this is correct. Check finally. No, nothing else. Sync source. I hope everything is correct. Back to the main pipeline. And here we have to debug it to see whether it runs correctly or not. Debug it and wait for the results. It is in the progress. The get metadata was successful. And all the activities ran completely and successfully. As we can see, we have input for get metadata. It refers to folders and folders dataset that we defined. The output is something that we expected. Yes, as what we expected. So we can see that, okay, we back to the SQL server, enter the SQL database and see, select star from staging customer to see whether it includes file. Yeah, exactly as we see, we have the uh, all the file that we are expected. But as we see, we have a duplication here that for the final table of customers, we don't have to see some duplication. But here at this stage, it works correctly. Check whether we have for the products, mm, oh, for the products we don't have, for the staging products, sorry, staging products, we have two products as we had in the CSV, and for the staging order, uh, staging orders, Yeah, this one that refers wrongly to customer ID 4, that for the final order table, we have to remove this. Okay, so far everything is okay, and we did completely and successfully the pipeline. The next strategy that for this stage we have is for some procedures, stored procedures that we define, we try to handle the cleaning the final data set, that some final tables we have should be without duplication, bad data or wrong data, clean data. So for this, I define the procedures that you can see in the description of the video, and then you can copy and paste, use it. I will explain what it works shortly, but you can find it in the description. Okay, for the first one, we define the procedure as the name of the load customers. We say, okay, begins with we don't want to see the how many records are influenced and see the result. Set the no counts on. Then instead of inserting the one by one the records, we define the procedure. It stores here in the store procedure, and when we execute this procedure after the running the pipeline, we are able to ingest the clean records, correct data into final tables. We say that insert to the customer table, customer ID, name, country, select the distinct. It should be distinct customer ID, and we check with the left join to prevent the duplication. And after the uh, executing, what was the name of this? Okay, run. No, we check, select star from customer. Okay, have nothing in the customer. Why? Okay, after the running this code, and we see that we don't have the duplication that we saw in the staging customer. In the staging customers, we saw two Bob, but here in the customer, with the help of the procedure, we see only one Bob. And the no duplication, we have to do the same procedure for the order and the products. I do one by one. Okay, uh, for the products, we define the procedure as with this name, same as the procedure. We say select these things records, and then only put those rows that are new, not previous one. We run this and then execute, and then select from products. I hope it works. Yeah. For the products, we didn't have a duplication. Now we have to do or define the procedure for the orders. For the uh, procedure for the orders, we have to define First, the valid orders that are distinct refer to correct product and product ID, customer ID. For the invalid orders, invalid rows, for example, that the customer ID is null, they are the missing order, we have to transfer them to the uh, error table or missing table. So we define some procedure. We wrote this bunch of code, but after a while we want to execute. Only we write execute the procedure name. Couldn't find the storage procedures. Okay, let's check what is that. Okay, we missed a comma here, and then after that we correctly. Okay, I need only the name of the this and delete execute this procedure. Then we check whether we have the correct information in the final order table, orders table, and yes, we see that we have correctly the order rows, because in the staging orders, as you see, we had two rows. One refers to customer ID 4 that we didn't have at all. So we have to remove it, but in the final final orders table, uh, orders, we don't have such uh, wrong information. So it was the pipeline that we created with the help of the Azure Data Factory, and then the scenario we discussed, it was somehow a real case scenario that we see in the business, and we try to finally have a clean table without any duplication and the wrong data. I hope you enjoyed, and please subscribe my channel to help me create more videos and practice together. Thank you so much. See you later.